to test the true position. And through the occlusions, that's what we're testing. And we're seeing that relationship of how we see the star versus where it is isn't what the globe is predicting. Now I'm going to go ahead and unmute you so you can ask your follow-up questions. Thank you for listening patiently. Go ahead.
There was no point to any of what you just said because I cannot see your presentation. Your presentation is a flickering green screen.
All right. I'm just going to go ahead and mute you. That's unfortunate that you can't see it or participate.
Anyone else see it? Is everyone else good? I'm good on my end.
I see it perfectly fine. Maybe his computer on his isn't working or something like that. It looks perfectly fine. I see the.
You can look on YouTube, Tony, as well. It's being multi-streamed or multicasted on different platforms.
Here's a screenshot. Oops. Here's a screenshot posted in the chat so you can see it. But we all use the same conceptual sphere for the modeling. We all see the stars. There's not a special different way that we see them just because the Earth's flat. We're saying that we see them in this dome of vision. Go ahead.
If you say that if you pick up a coin, for instance, and it looks circular when you look at it straight on, but if you tilt it towards you, it stops looking like a circle. If you are on a flat plane looking up at a circle from an angle, if you are not under the center of that circle, it is going to look like a tilted coin. It is not going to remain circular.
We see in a sphere of vision the stars across the horizon.
That is not an explanation of what I just said. You just saying there's a sphere of vision does not explain away geometry.
Both models use the same sphere of vision.
Yes, but in a flat Earth model, we would not.
If we see it the same, then it's the same. We're granting the
no, it's a disproof of your model. If you claim
completely different,
you're not listening to him. Listen to him.
Yes, I am.
Oh no, Tony, you're right. He's not listening to you.
Jeez. So if you are claiming a geometry for the system, I am pointing out that in your assumed geometry, if the Earth were planar, we would not see a circular path. You saying, well, we see circular paths, that's my point. My point is that the fact that we see circular paths is a disproof of your assumed plane. If we were flat and you were looking at the circle from an angle, it would cease to look circular. If you look at, for instance, you'll often see disc lights in ceilings. If you are directly underneath the light, yes, it's circular, but if you move off to the side, it stops looking like a circle and looks like an ellipse.
We're not looking at discs in the sky or what have you. We see in a dome of vision, and as the stars move across, the reason that they change position is due to our vision.
Are they round?
You guys say that it's due to the... Dude, we're not talking about a physical object, bro. We're looking at stars. There's completely different cosmologies on that.
How do you know the stars aren't physical? How do you know the stars aren't physical?
Well, my understanding is that Alan is still in like the initial like presentation part of the event. So I don't know. This isn't necessarily like open debates like part of it, right?
But this is my point. He's supposed to have a model of when these celestial objects are coming into vision and when they're not. So he has to have a model, and he is trying to claim that his model for this is more accurate than the spherical Earth model for this. In order to do that, he has to have a model for the motion of celestial objects that can be interrogated. He isn't presenting it.
And Tony, I was actually backing you up. And Shane, what I was asking you to do is just listen to what he's saying, because he's talking about an object. Now, if the lights are not round, they're not spheres, then fine. But what about things like the moon, which you can actually see that are circular? And to his point, they aren't going oval at the corners. Like if it was a celestial sphere, they would be ovaled at the corners and not still round. That's what he's saying. Does that make sense? Shane?
If you assume that the sun and moon are 3D physical objects that you can go to, etc., then yeah, that would probably be applicable. But we don't, that's not our cosmology. What we're saying
is what are they?
Yo, do not interrupt me, bro. In the middle of me speaking, you're just going to have to put you on mute for a minute here. So let me lay this out for you, okay? We're saying that we see in a sphere of vision, there's a ton of evidence that shows that vision is not Euclidean, okay? Just saying, we observe the stars, therefore globe, is retarded. Now, what I'm showing you in that picture is that the globe, quote unquote, the backbone of it, is using a literal limit, a hemisphere of vision. Okay. Now on a flat Earth, we have, guess what? Our eyes are the same. We don't have different eyes because the Earth's flat. How we perceive the celestial bodies move in the sky is based on our vision. That's it. So this concept of how a star changes in position relative to an observer is based on a sphere of vision, how you perceive it, how it changes angularly. So we're testing that. The globe says that they will move at 15 degrees per hour, 60 nautical miles per degree with their true positions. That's what the globe claims. We claim that they're, above us at all times and they're not truly going beneath our feet. So we can test this claim that the globe is making through occlusions. Because if it's observer-centric and the Earth is rotating, changing the elevation of the position of the stars, that's going to cause them to occlude earlier, regardless of either model, right? That would be a geometric fact that occurs because of the shape of the Earth. Now, that occlusion time never happens. What does happen, however, is relative to the observer, the time it takes for the star to move angularly over that arc length, it all of a sudden gets occluded before what's predicted using the 60 nautical mile per degree relationship in every single case. So the model we're testing, that you're claiming that we have to have something to test, yada, 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 we're testing the globe right now. If you want to test a different model or something, that's a different hypothesis, dude. We're granting the celestial sphere model. We're just saying that the change is due to our vision, not the shape of the Earth. And we're saying timing wise, 15 degrees per hour, the positions in the sky seem to follow that pretty good. So we're granting that as well. And we grant the 60 nautical miles per degree for testing purposes. Okay. So we don't have a different system or whatever, right? All we have is what the stars are doing that's observed. And that's what the entire models are based upon. Somebody took a Zenith's measurement of a star once and added 15 degrees per hour to it and constructed the whole model. That's it. So you have it in your head that like, there has to be a different thing. We see them shape into ellipses and whatnot. Bro, they're little point sources of light. They're little dots. How they move in the sky is a facet of our vision and or the shape of the Earth, assuming parallel light rays and all that. So we're testing that to see which is true. Now I'm going to continue on with this presentation. We'll do open back and forth later. But the point you're getting hung up on is irrelevant. Okay. And we're almost done here. So Goose's measurement ended up being closer for the apparent to apparent, and it ended up being a little closer for the apparent to geometric there, but geometric to geometric, still off. Now, on the more recent one that we did, following up on the Getaway Peak, this is right next to Getaway Peak. It's about, I forget the azimuth difference, but it's like 20 or 15 degrees or so
What's it called?
away from, yeah, it's called Kukakatitaki? I don't know. But anyway, this one ended up being 23 arc minutes off of the apparent to geometric there, and then geometric to geometric off by 23 arc minutes, 12 arc minutes for flat Earth, and it ended up being 2 arc minutes above. Let's see, it was positive. So apparent to apparent ends up being below the peak by 2 arc minutes. So mismatch there on all of the predictions, except for the fact that the arc length traversed relative to the observer is when the occlusion occurred. So let's see, next part. Now the new data that we have, we'll go over. So we got some new occlusions. Now they haven't been added to the sheet yet or anything like that, but I went through and got timestamps for everything so far for the ones that have potential to be added. So we usually look for stars that have multiple stars on screen so we can identify them by their pattern or whatever. So anyway, some new occlusions there. Scroll through some of these. A nice bright one there. Yeah, we got about 18 last night or 2 nights ago, and then last night we went out and got some more, which I'll show you guys now.
Nice.
So for this one, because we were wanting to test how that celestial sphere deviation at higher angles, we got nice. I think we're probably about 1 mile, maybe sub 1 mile away from this peak. And no. Oh, I haven't transferred them yet. Give me 1 second. We can talk about something else now, or real quick if there's any questions. I'm gonna pause real quick while I turn the C-Star on. I'll put those on so we can see them real quick. All right, while that's booting up, I will pull up the history of vision here. Take a look at that. Where was that?
Power on, ready to connect.
I don't know, Alan, if you don't mind, I don't know if you've done a presentation or not on the actual can't remember the first word, the dome of vision, the azimuthal dome of vision, I think it's called.
Mhm.
Like, can we maybe get a presentation on that in and of itself?
Sure, Shane's done quite a few of them already.
Okay, maybe I'll look it up. No problem. Thank you, Alan.
Yep.
Shane's about to spam you, Rob. Don't trip.
Okay, thanks, Shane. I appreciate it. I'm driving right now. I can't look at it yet, but I will.
Shane's like, crap, I gotta pause my game. Thanks a lot, beast.
I'm just waiting for someone to address the math and none of the peripheral nonsense where they just try to be fallacious and stuff. But like, someone go through Pikes Peak and show us where we're wrong. That would be a valid refutation. 34 weeks and no one's done it. I'd like to see it. Maybe Tony's the guy.
So this comes out to be about just an estimate. I think it's like 10. It's over 10 degrees off of the horizon. But here's some of the pictures and videos from last night. So yeah, here's a really cool one. Every star in the northern hemisphere set into this, I guess. Yeah, this was a really cool one. It's the most stars I've ever seen in one frame while looking at the horizon-ish.
And what mountain peak are you looking at?
Ooh, unclear at this time. We have not ID'd it yet.
They're gonna say the other one. unpredictable Takahiki
no,
or whatever it is.
no. We were driving home, and I was like, "Oh, we could just pull over right here and use this peak because it's like super close and the angle, so we're really close to it." So anyway, we went and got a bunch of measurements from here at different locations on it. So anyway, this will all be hopefully added by next week. We'll get all that in the spreadsheet, get it integrated in there. All right. So regarding spherical vision and whatnot, there's a whole history of that. I linked a screenshot, kind of a meme that I made that has a bunch of references in it, but one primary one that I would recommend to anyone interested in the conversation of how vision works. Let's see. You've been upgraded to Cel-Theo 8. Nice. God bless. Let's see. What's my Wagner? Of course. That's not how you spell Wagner. The geometry is a visual space. So in the first 3 chapters here, this guy goes over the histories of all the primary theories that were put forward to describe optics and how we see, the differences from the spatial field and the visual field, and how those theories fail, etc.
Nice. Little Wagner.
Yeah, but basically, right? We all let's see. Oops, let's run this one. So that's what we're testing there, right? Is the globe model work because the Earth is a globe, or do the stars change positions because of an optical phenomenon? If the Earth is a globe, then these occlusion intersections would be mismatched. They would be reversed. So instead of flat Earth being 11 arc minutes off, instead of flat Earth being 2 arc minutes off, it would be 11 arc minutes, and globe Earth would only be 2 arc minutes off. But none of that ever happens. So, and then of course we have the apparent positions with respect to the geometric and apparent to apparent, and we see that we end up with scenarios where the star will either be below the peak at the time or should have already been above it, and it doesn't actually occlude until that arc length difference relative to the observer is traversed. So, which indicates that they're not following the 60 nautical mile per degree relationship at these angles. All right, we've been over the refraction differences at, let's see, where did I add that?
I say like no questions yet.
Refraction 2. Well, refraction 2. So anyway, in this refraction section, you can see every angle band starting from 90 going down to negative 30. All the way down to negative 30, you can see how the refraction changes. All right. Now, everything hath been concluded. We'll do open Q&A now. Now, against my better judgment, I'm unmuting you, Tony.
Okay, well, thanks for being a fuckwit about unmuting me. I always
All right, that's enough.
Yeah,
Bye-bye, Tony.
that's enough of you. All right. Anyone have any questions?
was hilarious.
Yeah, I have a question.
What's up?
What mechanism causes the stars to appear to move?
What mechanism causes them to appear to move? So are we talking like
Gravity.
that? Well, no, they just move above us. I don't have a mechanism for it. Some people say that they're fixed to the firmament spinning, etc. Couldn't tell you. We just observe them moving.
Don't you think that is a bit of a hole in your entire experiment when you're basing all these measurements off of something you have no idea about?
Not at all, because the current heliocentric dynamics are based off of GMM over R squared, where the mass cancels out and it reduces down to Kepler's laws, which is just pi over periodicity. Nobody actually knows why they move in relation to one another. It's not a problem for us.
I was only speaking about the stars appearing to move in relation to us.
No, I mean, well, that's to kind of show you the difference. Like nobody knows. They just assert Earth rotate, where you could assume sky rotate, and they both produce the same thing.
Regardless of heliocentric or geocentric, it's still a globe. So I don't know why you brought up like helio math. But you were just elucidating how much of an explanation the other side does have. You have no idea what those stars are, why they appear to move, or anything about them. Yet they're the linchpin in your entire argument and observation. It seems like a misstep.
Yeah, the stars move above us. If you want a causal mechanism as to how all that works, you're going to have to ask somebody else. All we know is that they move. And the reason I brought up the GMM over R squared for the relationship of solar system dynamics is we also see those same celestial bodies move in the sky. It's asserted that the causal mechanism is mass attracting mass, yet it just reduces to kinematics. So nobody actually knows why they move. And in terms of them rotating, like I said, you could say that the sky is rotating, or you could say that the Earth is rotating. Both produce the same effect. Simply saying the Earth rotates doesn't make it true, right?
No, but the Earth rotating explains things like recession, right? Or the
Recession.
perihelions, sorry, like of Mercury, where they appear to recess across the sky. All of this is explained under the current solar system model with a spherical Earth orbiting around the sun. In fact, I just have to stress how little your side has in understanding of what these celestial objects are or what
so you just observe
doing.
and discourage. Yeah,
And,
observe
yeah,
and
it's a
declare.
working explanation. It's a working explanation. Rob, if you have an issue with any of astronomy, go out and research it and look at it yourself.
No, so I can observe and declare as well.
Yeah, that's Rob. You're not wrong, but please don't interrupt when the other guy is talking. But what I just stated about the GMM R squared relationship is that there are no dynamics as to why they actually move. It reduces back to kinematics. That's all anyone has ever had is kinematics, the observation of the motion itself. That's it.
Right, but the motion of these stars and planets in our solar system and planets outside of our solar system is explainable by the movement of Earth around the sun and the rotation of Earth. That's why we are able.
So listen, Rich, this isn't that hard to grasp, right? All the observations, number one, are done from Earth. They're all just a function of pi and periodicity. So what that means is if you see the sun go across the sky and when it returns to a year, if you apply that periodicity to the Earth instead of the sun, you could equally say that it's the Earth moving around the sun. Now, there's different ways that you could test that using a zenith mount filled with water, or you could build an interferometer to measure the absolute velocity. And when those were done, none of the measurements comported with the velocity of Earth having 30 kilometers a second. So
well, the motion of the Earth can be relative, right? To
it has to be relative to something, and it would be relative
Yeah.
to the ether. And in that with that measurement, there would be a 30 kilometer a second relationship, because
right. But you're missing my entire point. You're missing my entire point.
No.
So
Rich,
continue to miss it, but go ahead.
Rich, you're missing my entire point, because we just went over how the math is just kinematics, and you could apply it to any frame. It's frame independent because it's asserted as relative motion. So,
but we're talking about a working model and an explanation. When
It's just sophistry.
So what you're asserting as mutual exclusivity isn't mutually exclusive. So there's no difference. So there's no actual contention there. And if that's all you have to say about the conversation, I'll let you get your final words off, and then we've pretty much wrapped up here for your questions for this particular one. If you have a different one, feel free. I'm going to unmute you now. Go ahead.
Well, obviously, they're not equivalent, because the globe has a working model that explains the observable phenomena, whereas the flat Earth side just states the phenomena as brute fact and nothing more.
So on the globe model, what's the causal mechanism for the Earth rotating?
For the Earth rotating, that it has momentum?
That's not a mechanism.
The mechanism for the Earth moving? I'm not so certain.
What, didn't you just assert that that's not good?
Is it not good to have an answer? Yeah, you know what, it is. But when we can look at the observable phenomena, when we look at an observable phenomena like stellar rotation, that is explainable under the globe model with the Earth rotating. It's perfectly reasonable. Whereas under the flat Earth side, stars move because stars move.
Stars
Aren't you just saying about that? Aren't you saying that about the Earth, though?
Dude,
am I saying that about the Earth? No, I just said that I'm not sure. I'm not sure why it rotates. But my position,
I'm not sure why this guy rotates, bro. But the model itself is just based off of position and time, which is just kinematics, and that's not mutually exclusive to any model. This is why we need to use the occlusions to differentiate between model and reality, right?
The person who was trying to like throw it back on me by asking if I know how the Earth moves, at least I'm not saying I don't know what the Earth is, right?
What?
So when I ask how do the stars move, and you guys say we don't even know what stars are, to be analogous to what was asked of me, I would have had to say I don't know what the Earth is to say how the Earth moves.
Well, the stars, not knowing what the stars was in relation to saying how they should angularly change or whatever. Now, what we're saying is that we both see the same thing on either model, right? We're both using the same ASI grid to define positions of objects in the sky. We're saying that it's just a facet of our vision. You guys say it's a facet of the shape of the Earth. The only way that we could test this is by using star occlusions.
Wait, the stars move as based on our perception? I'm really, nope. I understand you don't. You're really explaining that you don't have any idea what the stars are or how they're moving. So, thanks for elucidating that.
Dude, you don't even know.
Glad I could help. All right. Are there any other questions or comments?
Real ones.
McToon's near. You got any questions, McToon?
Think how stars move isn't a real question. What's wrong with you guys?
Stars move on either model. We're trying to show something mutually exclusive. You specifically concentrate on something that's not. It's the same for both. So your point doesn't prove anything. Our point is mutually exclusive. Thanks for your participation.
Saying that it's included in your model because you observe it in reality.
All right. I honestly
they can't imagine anything other than the coordinate system that was presented to them. Clearly, can't even grant it to you for a second because you can't imagine a coordinate system other than the one that they were originally presented.
Do you know what's fascinating about that, Shalom, real quick, is that I was talking to someone earlier and they were like, but isn't everything heliocentric under the hood? I'm like, bro, every observation's made from an observer on Earth. How are you on the sun under the hood, but you're on Earth? But yeah, they literally can't conceptualize it being different. There's like a mental block there, even though the backbone of relativity theory is reciprocity between frames and even a general theory that applies to any frame to make them all equivalent. So super unfortunate to see that. But yeah, what was your question, Beast?
Oh, I was just seeing if anyone in here could actually steelman the celestial theodolite from the other side. That would be helpful. Maybe actually have some clarifying questions. Anyone on the globe side?
Is there anyone not clear what we're doing here and they would like to hear an explanation of it real quick just to understand it? Because I think if these measurements came back globe side, everyone on the globe would conclusively agree with it and immediately understand it, or at least pretend to. But because the measurements didn't come out globe, it's like a mysterious thing. It doesn't work, because of relative motion of the stars, yada yada. Like, you know,
Or your method is wrong.
Have you ever asked a globe person to make or validate your predictions, or you just make them in?
It's only been 34 weeks.
No,
yeah,
no, I'm
Jesse
asking.
Jesse went out and used our method and made measurements. These are his specifically from.
But he's not allowed on anymore. So have you asked anybody? Has anybody else besides Jesse?
What does that have to do with him making the prediction successfully and doing it? If he's just because he's not allowed to talk here doesn't mean that he didn't
does he
do
stand
that.
by those predictions? Or so I'm just asking. I mean, it's not a
Ask him. Ask him.
Okay. Has anybody else from the globe side agreed with your predictions for the globe Earth?
Everyone, because
Yeah, all
that's
of
where
them.
Stellarium. That's where Stellarium places the observer. So yeah, they all agree with how we're doing it.
You remember
Oh,
week
so
12?
they agreed.
Griff
They
and Jesse
agreed with
agreed?
your calculations for
Yeah.
what the globe would predict. Okay. All right. Thanks.
Till they understood
Yeah,
the
and-
implications, and then they pretended not to. That's what happened.
And if
Yeah.
anyone disagrees with the math, they are welcome to correct it. Actually, I think Embo once disagreed, and he gave me a different formula here. So if you look over here to this section, you'll see alternative derivations for the mountain elevations. For the old previous method was just doing some cosines with respect to the old central angle there. And then Embo hit us up with some actual spherical trig, gave us this. It comes out to 217, same thing. So they agree up to 9 decimal places. So every
good
globe
enough.
lad also agrees with us up to 9 decimal places, I would assume.
And what the other question I had is what's causing the errors, the significant errors in your measurements for flat or globe?
Ooh, great question.
That's
So
a
we
good
actually
question.
share the same error. Like the sum of these two differences is the amount of predicted drop over distance, and the error there produced by that is because the star isn't following 60 nautical miles per degree on its descent at 15 degrees per hour. It is following the 15 degrees per hour, but it is not following that descent rate. If it were, then these intersection times would, we would have had to wait for the 11 more seconds before it intersected. So for every single measurement, there's always, that discrepancy of it. And my interpretation of that is that the star's true position is not following that prescribed rate. And then when we go into the central angle stuff to verify how much the star dropped relative to the observer over that distance, which is also an angle because angle equals distance for globe, based on how that works. So we note we take the difference in their true position at the peak and at their true position relative to the observer, and that angular drop amount is always the exact same arc length of the distance that it would travel. So it's like you can think about it like the star's time-wise is traversing 50 kilometers, and at the end of that 50 kilometers there's a mountain peak that has a rise over run through this elevation here, and that's when it's immediately gets occluded before it even drops to that using the 60 nautical mile per degree relationship. So
why don't you factor that into your predictions?
Why don't we factor how much it's going to be, because we don't know how much the true position is going to be lingering like that. It's not something that we could readily predict. We would need like more measurements to plot it out. Because take a look at, so hold on a second. So take a look at this. So the celestial sphere predicts this blue line here, and then we don't know how much it's going to be lingering or how much it should be off or whatever, but we just have the data points of it being, of it not following that. So that's all we have right now for that.
So which ones? Okay, so those are the actual. Did you plot the errors from both the globe and the flat on this too, or no?
Both from the flat and the globe. So the globe would predict this right here, and then deviations from this blue line would be the error for both.
Okay, so where are flat Earth predictions on there?
Just where the there isn't one. It's just where the star was at the time of occlusion.
Why wouldn't it be interesting to put the flat Earth predictions on there?
Well, we don't know the angular deviation over as it gets closer to the horizon. The globe assumes that it should follow this blue line, but it doesn't. So we don't know.
So the flat Earth doesn't make a prediction for that particular
thing. No, we do not. That's actually why we are studying the higher elevation occlusions, because in this graph here, these angles are all low. We're trying to get angles that are 30, 40 degrees up in elevation so that we could see how it maps to the celestial sphere, so we can kind of get an idea of the deviation or whatever. Now, of course, that would be post calculated and all that, but I don't think there's enough data here to really.
So couldn't another interpretation of the errors that you guys are getting just be that the method isn't accurate right now?
If that were correct, then the central angles wouldn't line up. So no.
Okay, thanks.
Mm-hmm. Yep, that's why we say everything that we're doing here, can be verified also in Stellarium, because angle equals time. So all the relationships established, you can definitely confirm, where they should be with respect to the model making the prediction and go from that. So,
do you intend to publish this for scientific peer review or no?
I do.
Do you have a timeline for that, or a hope, I guess?
I do not, but it is something that I aspire to do. I started a mini write up to be kind of like formal about it on the introduction here on the on the Obsidian, but I think it's like way too technical because I linked it to some globe lads, you know, and they were like, "What the hell is the two sphere model?" So I don't know if I need to like I don't know if I need to change or if they need to change. You know what I mean? So but I do plan on writing out something formally and sending it out to different universities, etc. For sure. I think it's one of the most significant ways to measure the shape of the Earth without just assuming the shape in the first place.
Yeah, dude, every term you use, just do a reference. That's all. On the bottom.
Yeah, that's what I started doing on this. I was like, because it starts with cosmographia.
What the hell is cosmography? Yep.
The P. Tall's book about the two sphere model and how they have to be the same to use them.
Oh, I see. Yeah, you did start doing it. Yeah, dude. You should do that. That'd be awesome.
Yeah. So, but yeah. All right. Are there any other questions or comments?
Nope. Guess not.
How obnoxious was PhD Tony?
I'll self-publish it. Don't worry. I don't require, it to be accepted or whatever.
What if I were to review it as your peer? Would that satisfy the requirement? Do you think?
Ooh, so here's what I'm thinking. We started a little coalition there, and if we all agree on something, it is henceforth the truth.
And then if we don't agree, we can discount it and never examine it. Is that how it works? Okay.
You guys aren't turning into Globers now, are you?
We might start a globe coalition and a secret society based upon keeping the secrets. It starts with a handshake, of course.
I mean, you guys have started to use math. You might eventually qualify as Globers.
How dare you? Well, dude, I'm starting to think some of the Globers aren't even qualifying as Globers.
Yeah.
Because since we
started
started using the math, only a couple of Globers have stepped forward to, get a whiff of that math.
And
Yeah, just tell us where the stars go after they go to the horizon. Then maybe we can
out of your field of vision. Very simple.
This guy is so funny. Listen, I don't have any math or understand what you're doing, but if I could just say the same three things I've been saying for 5 years, I'll get a kick out of it.
That's so crazy.
5 years. 5 years.
My telescope says that the star's underneath me.
Yeah, right. How do you know the star's going beneath your feet, or is that just assumed?
Har.
Ha 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 ha.
On the other side of the horizon the next night. So
yeah, it's weird. They just flop to the other side.
The other side of the horizon.
Maybe just like scooched around, like right below the edge of the horizon, then just like snuck around, like through the bushes, like a crawling sniper or something.
Right.
Yeah. Like
go down on one side, come up on the other side.
Alan, can I ask you a question? Like, of all the, like, if you had to summarize in your mind, like a ratio, like what percentage of all of the, even when you add like refraction with and without refraction, when you do all of it, if you had to summarize all of it as like, is it 90% one way, 10% the other? Is it 95? Is it 80-20? What, like, in terms of like just all the results in terms of the shape of either planar or the sphere that they claim? Like, how would you say if you had to summarize it in one way, like how it breaks down or how close, where the needle is?
So in terms of geometric to geometric, which is, the cause of the occlusion, flat Earth 100%. For apparent positions, sometimes they match, sometimes they don't. And like by sometimes, I mean like it'll be either above or below, which doesn't lead to an occlusion. It's not the cause of it. If it's above it, then it definitely didn't get occluded yet. And we see in the videos how the stars behave when they hit the peak. They don't really linger. They don't set into the peak as if they're going through an apparent image, like a refracted image or anything like that. They just, they start to vanish as they hit that peak. And that's pretty much, so that like kind of takes out the position of like, the refracted interactions and all that. And because of the refraction amounts mismatch on terms of being either above or below, at the times you wouldn't consistently be able to say like, the cause of the occlusion was this. So.
Like for the side that where they claim the Earth is a sphere, like do they like how many do they have, and do they have any that are even close to actually giving the sphere result? Any that actually match it? Are there none that are even close?
Sorry, I was replying to Tony. What was your question?
No, like in terms of showing a globe, like are there any that even indicate that are there any that have even like hit the actual globe result in any consistent way, or even gotten it at all? What it would be on a globe, or just not even close?
No, only on the apparent intersections. Like for the ones we went over earlier, were like I think it was Blue Mountain, or let me look here. Yeah, they ended up getting closer on the apparent intersections, but that conflicts with other measurements for different peaks. So it's like there's no consistent consistency to it.
Have you done a standard deviation analysis on the results?
I have. It is over here in this section of the Obsidian. 1 second. So we did a RSS air analysis, which is just a standard Gauss distribution. You can find out more about that here. And then the air bars for globe and flat Earth based off of the occlusions are here. So, yes. And then
Alan,
the
when you
spreadsheet
said
here-
Gaussian, aren't Gaussian planes like?
No, this is
I
in
thought they
reference
had to be.
to a statistical analysis. So basically, to sum
okay.
up what it does is it assumes like 65% or something like that of your measurements are going to hit like the worst min maxes, and then it averages that out for the air bars.
Oh, okay. So just, yeah, it's a graph thing. Okay, never mind.
Yep. And then all of the information about that, also like everything that came from the RSS here, is on the spreadsheet in these sections here. Nope, that's air tolerance. Here we go, in the air tolerance section. So you can come here and see how we came to all of that. It was basically converting a Pi module into a Google Sheet, and then it just take the data from the data table here, and then it output the necessary numbers to make the graphs.
And do you have the analysis that includes the globe with refraction, those numbers?
The analysis that includes the globe with refraction, we do not.
Okay, because that's, the actual globe prediction. So comparing.
Well, the actual globe prediction is actually made off of geometric intersections like eclipses and everything else, conjunctions, etc. So that's what we're
Great
using.
scientific retort. Great scientific
yeah.
retort.
Thank you. And then also when you're trying to, make a circle of equal altitude, do cell nav and all that, you're actually subtracting out refraction to use the true position. So if you would like to include that and do that on your own as a side project, that would be awesome. And then I'll implement it into the spreadsheet.
I've already
put graphs.
The funny thing is, you did it. You just refused to acknowledge what the results are.
What do you mean?
Your own spreadsheet shows like the globe prediction, the white number, lightish blue, white numbers. We had this argument last week.
Yeah, where it's
the idealized globe.
Where it's 3 arc minutes over the peak at the time of occlusion, which doesn't lead to an occlusion. That's what if you want to do a thing off of a position where it didn't play out that way, that's great.
I'm looking at the time difference because you're measuring time difference.
I know.
Start with time difference, man. So if we get a better time difference than you are, that means we're more accurate than you are. Fucking, I know.
This time difference doesn't lead to the occlusion. If there was this much refraction and this was actually how much was there, this 19 arc minutes of refraction, then this star would have to go another 2 arc minutes before it gets occluded. It would still be above what you predict geometrically for the peak. If something's above the peak, it's not occluded by the peak, right? So you basing your position off of this is actually that's why it's not included. It means nothing. The occlusion didn't happen 17 seconds later. It happened at this time. So this amount of refraction isn't even tenable. Saying that it should be lifted up this much, because this is how much you need 1-to-1 in every scenario to explain celestial phenomenon. Going back to the Novaya Zemlya effect, right? 10 degrees of refraction to explain that in the Arctic, 4 degrees of refraction to explain it in the Antarctic over different latitudes. Hold on 1 second. Ranging from San Francisco to, I can't remember the place somewhere in Alberta, Canada. There's the amount of refraction needed to explain it is the exact amount. So this is like an untenable hypothetical that never happened. But if you were want to use that as your position,
the number that's almost twice as high in green is tenable and happened is your claim. So 2 minutes 21 seconds is untenable, but 3 minutes 52 seconds is just okay.
No, the star didn't. No, the star didn't even get occluded when we predicted because it's not following the 60 nautical mile per degree relationship. It occluded at this time. It occluded earlier than that.
Yeah, my point is,
we would need 27 more seconds.
Both the predictions have errors, but our error is smaller than yours. There's always errors.
Okay. Listen, guy. Listen. That's a great take. When we get into the central angle relative to how much the star had to move or drop relative to that observer, it's the exact amount of distance angularly between the peak and the observer. So there's the offset isn't created by refraction or what have you, because if it was, then the central angle distance would be affected by that, and there's never a mismatch in that. So if what you're saying was true about this refraction amount, what would happen is the occlusion would happen 17 seconds later, and there would be a mismatch between the central angle relative to the observer and the positions of the stars at the time of occlusion. There would be a different value, and they never are. So your position isn't tenable.
Use the same argument. If the numbers were switched around, is that what you'd be saying, or would you be saying 17 is less than 27? We're right.
If the numbers were switched around, I'd be a glober, dog.
You'd be a glober, yeah.
So if the globe numbers were worse, you would be a glober.
If you understood,
the globe numbers were less accurate than the flat numbers, you would become a glober.
If the geometric intersections at the time of occlusion or emergence were closer to what the globe predicts, then the Earth would be a globe definitively.
They are close. That's what your spreadsheet says. That's the part that kills me. Your own sheet. I didn't do a bit of this work. It's all yours. You say the globe's more accurate, and you don't believe your own numbers. It's hilarious.
Listen, dog, we're talking about geometric intersections. You're talking about an apparent position that didn't follow the amount of actual refraction 1-to-1 as prescribed to explain every other phenomenon if there was no mountain there. So I could give a fuck about this number. This is super irrelevant to me. You're holding on to this for dear life because that's all there is. These numbers don't reflect what the globe actually predicts. It's closer to what flat Earth predicts. And
I agree. The pink
that's
numbers aren't what the globe predicts. Like the pink numbers are bad. That's a great straw man, but that's not what any of us are predicting. So the fact the pink numbers are bad, no surprise. We agree.
Okay, what numbers are you predicting?
Hold on a second. For geometric intersections, these numbers are not bad for the globe. What I meant when I was saying they don't reflect the globe, I mean they don't reflect it in terms of like it gives evidence for the globe. Now, this is exactly shut up for a second. This is exactly what the globe predicts because they're basing it off the observer. You can go into Stellarium, enter these times, and get where the star's true position is relative to the observer. So a geometric alignment for let's go back to Pikes Peak. So the geometric alignment for this at 217 is exactly observer-based predicted, and this is the intersection difference between them. Okay, you make eclipse predictions, conjunction predictions, all celestial phenomenon aligning is based off of true geometric intersections, not the apparent positions. Number one. Now,
that's your
significant. Yes, and the significance of that is because an apparent intersection doesn't cause an occlusion. Number one. This is why Mike became a flat earther, because when he went over these intersections, they should be reversed if the Earth is a globe. The full arc length should never be traversed relative to the observer, because the only thing at the end of that is a mountain peak with a rise over run. Before that, there was a chance that it could have been a peak with rise over run minus globe drop, but that didn't happen. So the important fact of this is these geometric intersections and this arc length and the full arc length relative to the observer and the peak, because that same arc length is also what defines the star's drop over time. You may speak now.
So, I mean, there just isn't a lot to say that I haven't already said. Like, the number in pink is a straw man. Like, yes, I acknowledge that's what the geometry without refraction would be, but you can't just ignore refraction. That's the core mistake you're making with your whole process is you pretend that using an occlusion means you can ignore refraction. It doesn't. You can't. Once you include refraction, you got to use the numbers in white, which are the more accurate ones than yours.
Hold on, wait. Can I ask him a question, Alan? Check this out.
Yeah, one second.
Well, how much does this... Okay.
Listen, if your refraction hypothesis mattered, there would be a central angle difference. There never is. So we must do this and untenable. Go ahead.
Okay. Maybe I missed, like, I haven't watched all your presentations, so it's possible I've missed this. When you say central angle difference, what do you mean by that?
What I mean by that is that the observer is, some arc length away from a star. I mean, from the mountain peak, right?
Yeah.
Now, at the time of emergence or occlusion, we reference that arc length. Okay. We subtract the position of the peak, of the star at the peak from the position at the observer. That total difference is the arc length between the peak and the observer. So what that means is the star was able to traverse that distance of the arc length, and then it immediately got occluded. Okay, if the Earth were a globe, it couldn't have traversed the full arc length. It would get occluded earlier because the globe predicts that the star is moving at 60 nautical miles per degree, 15 degrees per hour. So it already it intersects with 217 before it does with 230 relative to the observer.
So is this just a restatement of the whole, like, it's off by an arc minute or 2 arc minutes or whatever, like you were saying earlier? Is that basically the same thing then?
No.
Okay. Maybe I am misunderstanding it. My cat's
So
screaming. Please let me run away in a minute.
No worries.
Yeah, but go ahead.
What was your question, B? Sorry, I had to.
No, it's all good. He made a claim. He said you guys are ignoring refraction. Like, we need to take refraction into consideration, even with the collusions. My question to you is, how much is a star refracting when you can't see it?
That's a question to me. I mean, whether you can see it or not doesn't change the path of the light. It just changes whether the path of the light intersects your eye. So it's doing what it does in the atmosphere, whether there's a mountain in the way or not. It's just
So how much refraction needs to be added in if you can't see the star anymore?
I mean, what you do the physics, you figure out what the path of the light would be, and that tells you the answer. And I mean, this is why I pointed his sheet so much, is he's done the math. That last number is the prediction with refraction for when it would be occluded. So.
Oh, okay.
So it gets occluded before the full amount of refraction gets used. This isn't a straw man of your guys' position. It's showing you that there's not that much refraction. That's not a tenable position to use for a metric for anything.
No, I mean
the occlusion. If this were true, then the distance would be different for the central angle when you subtract these two from one another relative to the distance to the observer and peak. But it never is. It's always exactly as soon as it hits that arc length, it's done. Every time.
Might have to think on that a bit.
All right.
I'm pretty sure you're wrong, but I'm not sure I can point a finger on why well enough to make a real argument out of it.
That's fair. So think about it kind of like this, right? if the Earth is a sphere, right, we're taking this little arc length section of 27 arc minutes between us and the mountain peak, but the complementary angle to that is 80. What was that? Would that be like 89.33 or
89.33 or
something like that?
something?
Yeah. So it would be like 89.33. So if you multiply that out with nautical miles, it completes a 360 degrees. So only in that small section between observer and peak, where there's two possibilities, one is rise over run to the peak, the other one's rise over run minus globe drop. The exact amount of drop, relative to the observer, is that arc length before it gets immediately occluded. And if there was refraction differences, then it would linger, then the apparent position would linger on, and it would create a mismatch between the arc length and the difference at the time of occlusion.
Okay. Would it not also be the case that the 11 seconds the other way would also be a central angle problem then?
11 seconds the other way.
Like the green number. If that was, would that not also create the same problem of the central angle issue?
The apparent position would be what, 245? I see what he's saying, Alan. You see what he's saying?
For the apparent positions,
right?
Yes, but I think for the would it be for the true positions to fully traverse that, it would it would also change it. It would also create a difference in the central angle. I'll work on making a thing to like simulate that out so we can see the differences.
It's a good point. I'll say yes, actually.
Because
Okay.
it should, yeah.
Yeah. Because basically my take on this is all experiments have error. Like the fact that your numbers are 11 seconds off or whatever the number might be, that by itself is not a huge problem. You want to analyze and understand the error. But like the fact there is some error is inevitable. You're not using atomic clocks. You're not using like theodolites. You're limited by reality. And the fact that you're not doing this on a massive research grant either.
Limited by reality, I like
there's going to be some error. But we'd want to understand like what the error is and why. And if you just say that your prediction has error, our prediction is good, like you got to at least analyze the error of both sides using the same approach. So that's more or less what I'm from.
Oh, I absolutely do. That's how I ended up finding out that the relationship between our error difference and the globe's difference for the intersections is the sum of that is the half central angle. What they would predict as drop over distance for the earlier occlusion to create the central angle mismatch. So like, in other words, instead of being 27 arc minutes for us for that full traverse, the globe should occlude around like 15-ish arc minutes traversed. It shouldn't be the full 27. But yeah, I will work on making that more clear. I started it kind of down here a little bit, but I'll dress it up. All right. So that is a pivotal part to understand. It's a good question.
Fair enough.
If there's more,
so have a good one.
I have a question. If there's more, I'm looking at Shane's graph there, the little GIF. If there's more refraction from the peak to the celestial body, would that strengthen or weaken your case against the globe model?
If there was more refraction from which position?
The peak of Higgs Peak to the celestial body. Right now, the star. It looks like from the graph. I don't know if this is probably just because it's graphics. It looks like it's kind of the same arc of the light bending down to the peak and onward. But in reality, it should be a lot more after the peak. Would that help or hurt your case?
Well, if there were actual refraction conditions affecting it, like I was just discussing with Auladius or Alsadius, there would be central angle differences. So I don't think that it actually matters because when the true position intersects, it seems to immediately cause the occlusion.
Cause the occlusion. Well, it's a combination of both angles of deviation, or all the angles of deviation from the viewer to the peak, all the way to the star as well. Well, through the atmosphere. Not
right. You would expect a changing of it, but that doesn't seem to be the case. But what that would do is it would delay the occlusion, and it would make the refracted position intersect with the true position. It would make these numbers a lot more closer to what would be kind of what I would consider a tenable position if you were going to say that the true position was occluded by the geometric position of the mountain peak. These numbers would have to be like in the arc second range rather than multiple arc minutes above, because we can definitely measure arc minutes above something like the occlusion wise. So if they're up in the arc minute range, I would say that the hypothesis is untenable because it's if it's above it, it obviously couldn't be occluded by it. But if there was like actual conditions affecting it like that, then these numbers would be lower and more closer to what the globe for that to predict instead of being over it or under it in some cases. Like North Peak is devastating.
Can I ask Xander?
I've got one more question.
Oh, never mind. Go ahead.
Yeah, you might have covered it. But do you have any observations in the southern hemisphere? I asked you this before, and you said you were looking into it.
If you could.
No, we don't have any southern hemi yet. And if you're in the southern hemi and you want to make, what's the bounty at? Is it 300?
200?
Say 300.
Did you put 300 over there?
I might have. Let me
I
double
think
check.
it's 200 last time I heard it.
Let's see. Celestial Bounty, 200 per
Oh,
qualifying. So we'll do, if you're in the south and you can get a measurement that is over 128 kilometers, we'll do $300. If you're sub 128 kilometers, we'll do 200. So, so let's lay out a couple things here. You can find out more about that on here, on this website here. And we need a couple of things, right? We need your latitude and longitude. We need the lat and long of the peak that you're looking at, or at least its name. You can find that out from websites like Peak Finder, etc. And for the best occlusions, right? If you just get one star, including the mountain, that's not super helpful. What we need is like a series of stars, at least like 2 or 3. And if you can get occlusions where there's multiple stars on screen, that'll help us identify the stars later, because sometimes it can be really hard to identify them. So if you're shooting at night and you don't know the exact, azimuth that you're looking for the peak and whatnot, then your occlusion is going to have some additional stars in it so that we could reference it. If you're lined up with the peak exactly, et cetera, and you know your ASI, then a single, a couple stars or whatever shouldn't be an issue, because we can line up the azimuths. But
What does your model say in terms of what would you expect from a southern hemisphere prediction? Would it be different?
So the differences here for the star's position, true position, not following the 60 nautical mile per degree. 1 second, maybe I could show you exactly. Did I close it out? Oh no. Okay, so in the north we have like this amount of deviation here. I suspect that it will be a greater deviation in the south. I suspect that the intersection differences will be off by more.
What are you basing that on?
Just that the south would be bigger, would be larger. But the coordinate system is made off of symmetry, like force symmetry to the true positions. So like coordinate system wise, it's symmetrical, but I think in reality the south is bigger.
and historically, the South was always harder to map.
Yeah, it would be awesome to get that data. So getting like the long distance on it would tell us the most extreme deviation to it, like the North Peak measurement here. We would see just how far it's deviating from the celestial sphere. But
where do you get the rise over run on your graph?
Rise over run comes from the mountain elevation and the difference between observer elevation and mountain elevation at sea level. Oh, I'm sorry. That's for the elevation. For the distance, for the run, that's just the distance. So we take the arc length from that. So we take the latitude and longitude and do Haversine to get the distance.
The Haversine is a globe formula, right? I know that you've been asked that before.
Yeah, no problem. Yeah, so Haversine's a calculator, and it requires a radius value for it to be useful to. Like the whole model is based upon that. So to calculate distances between that, you have to use the radius. Yes. But my position is that it's a coordinate system calculation. It doesn't have to do with the position of the actual ground. It has to do with positions of where the stars were, because that's what defines latitude and longitude. So the coordinate system is spherical, therefore requiring a spherical calculator to compute distances on it. You could also take the chord of these distances, and it comes out to be, I think for Pikes Peak, there's like a 14 centimeter difference. So like at these distances, the difference between a great circle and a chord is negligible.
I appreciate it.
But, yep, I prefer the celestial, or I prefer using the Haversine though, because it's basically with the radius of 6,371,000. That's the the celestial sphere that they use for the backbone of everything. So it just kind of makes it nice and uniform. Is what we were getting into. Mike and Jesse were using different websites to compute the distances, and they would like change by a little bit. And it was dependent on which website you were using and which model you were using to compare it to. Because there's like a polar radius thing where they add like 20 kilometers to the North Pole, and then like 20 kilometers to the South Pole or whatever. So there's like a plus or minus there for, anyway, there's like, long story short, they're like getting different distances and comparing and all that and stuff. So I just centralized it to, whatever the lat long was and the great circle is close enough for me.
So why don't you use the Pythagorean theorem?
The Pythagorean theorem is rise over run. So like, this is all fucking.
But like in terms of making your calculations, like a squared plus b squared, you should be able to like calculate the angle and.
Well, for the central angle stuff for the globe, we use the 2D Euclidean projection, which is where the sides add up to 180 degrees, using the side A, side B, lowercase a and b, and all that for the angles and stuff. And then rise over run is literally just that is verifiable by the Pythagorean theorem. So I'm not quite sure.
Well, for the run, like, can you use the Pythagorean theorem for the run?
You can use it for anything on this spreadsheet. I don't really understand your question. This is all based off of triangles adding up to 90 degrees or 180 degrees. So it's all Pythagorean.
Is your spreadsheet available to like a read-only version, or
Yeah.
You might have
So
posted
Make
it
a copy
earlier.
of
I
it
just got
too.
to the conversation.
yeah,
All right,
so
cool. I'll
what
take a
you'll
look at it.
what you'll have to do is make a copy of it because of the drop down menu.
I
It
got
doesn't
you.
allow users to edit it. But yeah, you can make a copy of it and you're good to go.
Appreciate that. Yeah, I'll take a look at it. Thank you.
Yeah, Rise Up
Mhm.
Run's just a 90-degree triangle.
Yeah, I got you.
Yep.
I'm gonna look into it before I ask my question.
Yep, no worries. All right, lads, it's been about 2 hours. Thank you all for your time. If there are any further questions for closing or whatever, we can do like maybe 1 or 2 more. But if everything's pretty much wrapped up, we will go ahead and close for the night. We'll be back next week, hopefully with the data, or at least some of the data implemented from the new observations here.
I just
And,
wish flat earthers used math.
Well, you know what they say. You can make spaghetti using tomatoes or using ketchup. If you use ketchup, it doesn't taste quite as good. All right, lads. I'll be back. I'm gonna mute while I do the outro. But the presentation thus has concluded. Tony, I saw you were asking some questions during the thing. I missed most of them, but if you would like answers to them, if you send me a DM, I'll DM you now so you can have it in your history. But if you send me a DM of your questions and comments, I will answer them. I saw some of them were worth answering, so I will definitely.
Well, it's not for my benefit so much as your own. So I noticed that you're asking for GPS coordinates. You should let your observers know what accuracy you require for your results to be meaningful. You're not requiring GPS altitudes, which means that you are using some form of digital elevation model. It would be useful for you to know which digital elevation model you're using and what the errors are associated with that. Whether or not your rotation, whether or not stellarium includes oblateness and variations in oblateness, whether or not your calculations include rotation. You keep on using 15 degrees per hour. That's the wrong number, only slightly wrong, but it is still the wrong number. And it varies through time. Length of day
Varies for
calculation
latitude as well. But yeah, we actually do have that in there.
And of course, celestial latitude of points on Earth's surface varies through time as well. So you're not there yet, but you're getting into the point where you need to do these things with sufficient precision that they can be ruled out as potential contributions. And I'll echo what Alcidius said before, or Alcidius, however you pronounce it. Claiming that refraction can be neglected for this is not a safe assumption, and I don't think. And your attempts to make the argument I found extremely difficult to follow. And I have a degree in mathematics, so you're not making. You seem to think that your case is watertight mathematically. To me, it still seems a bit garbled. And when you're comparing two models, globe and flat Earth, you need to fully describe both models. And it feels to me like the flat Earth model is not fully described. There are portions of it that you have not yet explained to me certainly I feel that you haven't explained in sufficient detail why star trails should be circular if the Earth is flat. If the Earth is flat, the geometry should dictate, and your arguments about the psychology of vision don't carry any weight because we get the same results when we use cameras. So all of this stuff about the non-Euclideanness of human perception and human visual interpretation, that's a red herring. We get exactly the same results, or pretty much the same results, when we use cameras as when we use the naked eye. So that is not an argument for why you get these effects. And so I would encourage you to sit down and work through your model from the ground up, because the fact that star trails and celestial object trails are circular is a major problem for you. You can say it's just the same as the globe. Well, it shouldn't be if the Earth were flat. If the Earth were flat, you shouldn't be seeing this. And you're just saying, well, it happens, so obviously that's how things work. Well, yes, I would argue that's a good reason to not think that the Earth is planar. And you need to. So you're starting from the point of view that the Earth is planar. Okay, that's a great starting point. I start plenty of my arguments from that exact assumption. Now let's work through the consequence of that. How, if the Earth is planar, do star trails show up as circular for everyone? We don't need to discuss that now. But it feels like a question you need to be able to answer.
Well,
Very
I
good.
would like to add a couple of things because some of them are already accounted for in there. So the latitude dependent variance and positions of the stars using 15 degrees per hour plus or minus the Lati variance. You can verify any position here that's calculated. There's a time interval associated with it. You can go into Stellarium and check the true position or apparent position, whatever the calculation time is for, and confirm that the star is at that angle into Stellarium. In other words, the spreadsheet matches Stellarium, and any timing and angle relationships are described, within that. We've compensated for that as much
That
as we
doesn't answer
can.
my question.
Well, it answers some of it to start with, and
No,
then
because does
all right,
Stellarium,
all right, yeah, no, it doesn't. Stellarium uses a radius of 6,371,000. Otherwise, we couldn't make the same angle predictions. So they use the idealized celestial sphere, and that's what we're using as well. And then in terms of elevation differences for the data and whatnot, we're using the GNS overlay on Google Earth, and then you can see what they've mapped out for elevations, and then compare that to what the elevations are said on Google Earth, and those tend to agree with each other pretty good. And then there's also a website called peakfinder.com. If you go there, I'm pretty sure they're referencing something similar to what Google Earth is referencing, because their numbers very
That's
strongly
horrible.
agree with those elevations as well. Oh, is it?
Yes.
Well,
Google.
listen, hold on one second before we get to that, because I'm about to dip. If that's horrible and it doesn't work, please provide me with the correct elevations and where I can get them, and then we'll go from there. But just saying it's horrible is low-key retarded, because it's the fucking GNS, dude. Like, it's a different number now. Like, come on.
Before you run though, IC Spin did say yes if you had time for just one more quick question, right? IC Spin.
Oh,
Yeah. Just quickly, if you're able to calculate the elevation angle to a peak, let's just say Pike's Peak, for instance, and you know what the measured peak height elevation is, then couldn't you just calculate what your run should be based on the Pythagorean theorem and doing a simple trigonometry calculation to calculate what you would expect the
Yeah, if you
distance to
already
be and
had-
compare that to the globe?
Yeah, if you already had the angle, you could.
Well, you can measure the angle though from your location, right? And then you can look at, what it should be predicted on a flat Earth, say the Gleason map or something similar, where it has the continents laid out according to what a flat Earth might predict, and then base the distances on whether or not it matches flat or globe, right? And then you could simply reverse engineer like what kind of shape you're on. Would be my
Well, not really. And then, because like at these distances, the difference between an arc length and a chord is only 14 centimeters. So like for Pike's Peak, for example, 50,000 meters, that's 50 kilometers. The difference is only 14 centimeters. So reverse engineering what it should be versus what it is or whatever is,
So the reason that Google Earth is bad to use for elevations is because the elevations in Google Earth are given relative to local sea level, and local sea level is assumed to be 0, but local sea level varies the height of that relative to the implicit datum. And so if you're using 2 points and they each have different local sea levels, you've got the difference in elevation between them is not the same, and sea level can vary globally by plus or minus 100 meters. So using Google Earth in order to calculate elevations is not a valid way of doing it, and certainly it's not something that you should be doing if you have any pretense to surveying expertise.
So check this out, big dog. Not only do we use Google Earth, we also use the GNS overlay, which shows the topographical elevation for those locations. We compare that. We also compare it with what Peak Finder says, and also when you go to Wikipedia and look at the names of the peaks, they have the elevations published. All the elevations agree with one another. So if you're saying that that's not good enough or whatever, then you'll have to show me where there's an actual difference at. Because if you go to our spreadsheet and you look at the mountain elevations that we have, and you go to try and confirm your own mountain elevations, I think you're going to find that there's not much of a difference.
What about the observer altitude? Right. So you've got the altitude for the peak. Fine. You've got the yes, Alcidius. That's the geoid spheroidal difference. Over 128 kilometers, it probably isn't that large in most areas. But for instance, if you're working along the Indian coast, 100 kilometers is enough to introduce a few meters. But the other point that I would argue here is you know the peak height with you claim great accuracy. I still think that if you're using Google altitude there, you're wrong. But it's the observer height. The observer height also features into this as a problem, right?
No.
Well, if the observer height is wrong, but the peak is right, then your whole model is based off of shit that's not correct. But I can overlay the GNS map over it and just get the same things. And my friend Eric also is super, he's a globe lad. He's super into GPS stuff. He was verifying the, what is it, the orthometric height, using all of that and the differences. There's everything's spot on. There's nothing wrong with this. Now, you can keep hypothesizing your scenario, or you could pick one of these from the spreadsheet and show me where the elevations are incorrect. Until you do
that's
that,
what he should do.
then until you do that, then you really don't have an actual argument. And I appreciate your contentions because those are valid, but they're already taken for, and it's as accurate as we can get down to GPS orthometric transformations. Apparently,
what I'm doing is pointing out potential points of imprecision. I'm not necessarily claiming that these effects are large, as Alcides is pointing out. They may not be. All I am doing is pointing out potential points of imprecision in your current formulation. And if you're not prepared, and okay, you're not prepared to do the work to make it more accurate, I'm not going to do it for you. That's fine. You've had them.
1 second, dog. You're not going to reframe that to you haven't done the work to make it accurate. Did you not fucking hear me compare it to 3 different sources and an additional orthometric GPS height from a person who believes in the globe? You're either not hearing me and you just want to repeat what you're saying, but that's a non-point, and I don't need to be here for that. So I'm going to go ahead and dip, and then you can just talk about it while I'm not here. That would be preferable to me.
Said you almost got it, kid. You're almost there.
And is it? Yeah. I think you're coming on a little strong. Your points are not wrong, and these differences do exist. They can be added up, but leading with the 100-meter difference, I think is overstating, because that's the difference between a point in the middle of the Indian Ocean versus a point in the middle of the Canadian Shield.
Well, no, Alcides, that would be 200 meters. So sea level varies by plus or minus 100 meters. So it goes down 105 meters below the datum, and it can go up to plus 100 meters. Just going along the coastline of India, for instance, sea level changes in altitude by 50 meters. So from the southern tip of India up to the northeast or northwest, you've got about a 50, 60 meter deviation. And admittedly, you're right. You're talking about 100 kilometers as opposed to 500,000 kilometers. And for the most part, the geoid does not vary by that much. But I am pointing out that there are errors in DEMs, and so being specific about the DEM that you're using for this calculation, particularly given the level of precision that is being applied here. And you're right too. I'm coming in with third order, fourth order corrections, and you're correct. You're entirely correct that there is a first order problem here, which is the refraction error.
Yeah, this is the thing. I think that it's not that you're saying is wrong. I think that although honestly, the fact that he keeps the refraction thing has been litigated so many times that it's kind of beating head against the wall. So maybe your approach to getting them more accurate is the worst thing, but I don't know. I think you're right. Yeah. Yep. And I think just as a matter of general etiquette, if you're going to be quibbling, you probably want to come in a little less heavy.
Okay, fair enough. But it's sort of the entire assumption that you could just use a Google Earth height kind of ticked me off, because famously
he didn't say that. Stop saying that.
Well, he did multiple times. He said that he used the Google Earth height. Then he said that he compared it with the GNS overlay. He did say that, and he said that he compared that with orthometric heights from a.
That's 3 different sources.
That is 3 different sources, but to say that he didn't say he used Google Earth heights is not true. He did say that. So
while frame it as if he only did that.
And you're interrupting me explaining why I take issue with that, as though I don't have any right to take issue with that. I do have a right to take issue with that, because GPS positions, orthometric heights, these are the fields that I work in professionally, right? There are problems with these assertions and what you're measuring height relative to, right? The datum that you're saying. Google Earth, for instance, just assumes that sea level is at 0 height. So obviously, the height of an individual near sea level is in error by the geoid separation at that point. So for observers at low altitude, observers that are near sea level, you're instantly talking about a height that is in error by 50 meters in some by 100 meters in some portions, right? So to claim,
right.
Pardon?
Not right. What are you referring to? Are you referring to a specific observation, or are you just bloviating to bloviate?
I assume he's talking about the Indian coast example, which is I think the.
Well, I'm talking about the Indian coast. If you make an observation there, but if you even a 20 meter, if you're at low altitude and you're in error by 20 meters of the observer height, what impact does that have on the accuracy of your calculations?
Yeah, which
Right, let's
one are you
assume-
talking about?
I don't know how many of the calculations are taken from low altitude.
I mean, maybe it would not be the
All
worst.
of them?
Because also, like, if you work in this field, you're much better at this than I probably am. Might be worth it to just take like Pikes Peak, 'cause that's always the one to start with. Do the actual numbers for that, see how much of a difference it makes. Because if it's like a foot, then nobody cares. If it's
Yep.
like 10 meters, well, that starts to really affect
Thaddeus,
things.
by the way, your mic is, you sound like you're underwater, by the way.
Yeah, I'm walking around on my cell phone and speakerphone, so.
He's still comprehensible.
Bro, I mean, if they're talking like a 27-second difference, that's pretty considerable. You think of how much different, how different that is of what it would be if it were a globe. And they just don't seem to actually match anything about a spherical geometry of the actual Earth, and it is problematic for the globe model that it does not match.
Well, yes, except that if the Earth were planar, we would not have circular star paths at all. So the fact that they're using circular star paths and saying this 27 arc second problem doesn't completely match the globe. And as Alsadius points out, that's only if you throw out refraction effects. So if you incorporate refraction effects, all of a sudden the globe does fit a lot better. But the very fact that you're talking about circular star trails is an indication that the Earth is not planar. And then you're claiming, well, now this minor quibble over here over the occultation timings, that indicates that the Earth is probably flat. No, it doesn't. It indicates, and you are treating stellarium as though it is gospel on this, and it absolutely isn't. There are, you could, given that it uses a spheroidal model rather than an oblate spheroidal model, the elevation of the Earth, the center of Earth to observer separation can be in error by 10 kilometers for mid latitudes. So that's going to change the timing that you get quite considerably. There are. Yeah, certainly. The oblateness, so the oblateness is what, 20? The oblateness is plus or minus 20 kilometers, right? So if you're at a mid latitude, if you're midway between the point where they cross to either the equator or the pole, your distance from the center of Earth is off by about, let's say, 10 kilometers. So if stellarium is using a spheroidal Earth, stellarium is using standardized refraction estimates. It can't calculate real-world refraction effects. And I'd really like to know the assumptions that stellarium is making about nutation and tidal effects. As Alsadius says, these are all small effects compared to refraction, but they all add up. And you're treating stellarium as though it is a perfect spheroidal model. I would argue that based on the fact that it doesn't even include oblateness, it isn't.
Okay.
That would be enough. That would be enough to treat the claims with some skepticism coming out.
Some Globers in here would think that's heresy for you saying that. Number one. Number two, if you have a better technique or way to, that you think is better, could you please provide it?
Yes, I suggest you go to the International Terrestrial Reference Frame website and look at how they do pretty much the same observations. So one of the except that they don't do it near the equator, they don't do it near the horizon where refraction effects can be expected to be biggest. They use zenith observations to measure variations in length of day and variations in celestial latitude. And they do this with great precision. So I suggest you go to that website and look at how they do things, because they've described things in exhaustive detail.
Okay, so they still use 2000 epoch.
No, they count from the 2000 epoch. So they basically the ITRF uses time measured from the start of 1st of January 2000. That's where all their times are measured from.
But we also need the peak to be far away so we can count the curvature.
Well, besides that, let's just say we take the exact same data and apply the RF, International Terrestrial Reference Frame? Okay. Is there a specific program that you're aware of?
The length of day program. They measure precisely when stars come overhead, and they track the time between subsequent zenith appearances of stars. So you're talking about high precision celestial observations, and I'll point out actually that the same thing is done for the moon. You get grazing occultations of the moon where astronomers get out and form a sort of north-south line, and they all watch this star which comes down the side of the moon, and they measure when it disappears behind one of the moon's protuberances, be it a mountain or a crater or whatever. They measure where the star is visible and when it isn't visible, and they keep very precise records of this sort of thing. So this is a demo, and they do this because it gives us information about the shape of the moon. Sort of similar, it's a similar thing, except they go out in teams, they present themselves north-south, they make sure that they're synchronized with the UTS, is it the UTC signal, and they do these observations. So people, that's kind of a side issue on the nature of the moon, so we can demonstrate that the moon is actually a physical object because it has a geometry that we can measure. But regardless, yes, the ITRF does these observations, but it doesn't do them at the horizon because the horizon is the least accurate place that you could choose to do these observations.
So we shouldn't be using the ITRF. All these observations are near the horizon, right? That's kind of the point.
Well, to say, yes, you can do a crappier job than the ITRF, fine. A more error-prone and a more inferior observation set than the ITRF, fine. But if you want to know how the professionals in this field do it and how to do it better than you currently are doing it, you might want to look at the ITRF.
I already got 15 tabs open, but I'm trying to find out what you're talking about, and then I want you to kind of stick around so then I can actually present it to you to make sure it's the correct one. Because then when we do the calculations with the data that we have with this specific reference frame, we can actually see the differences if there are any, and if there aren't any, then what? What would be your argument?
So my argument is that you're not doing a very accurate job, and that there are people out there who are doing a more accurate job and can measure these things.
The same argument?
Well, they're using observations of celestial objects to test the rate at which celestial objects cross the sky. Right. That is kind of Alan keeps on pointing out this 15 degrees per hour. It's not exactly, but whatever. We can measure variations in that using the length of day observations that the ITRF system has pointed out. So if Alan seems to be claiming that there is some deviation from the 15 degrees per hour as the stars approach the horizon. Is that not what he's saying?
Hold on, sorry, I'm listening to a video trying to figure out how to incorporate this.
Real quick, PhD Tony, if you're going to insinuate or beg for oblateness for the spheroid, then how would you not have to have a similar celestial model that matches that with that? Because of, if you've got two different ones, if you have a spherical celestial model and an oblate, terrestrial underneath, and how are your GPs going to maintain with that?
So there's a difference between geodetic and celestial and geographic latitude, right? These coordinate systems are not the same. So there are offsets between them. And part of that is due to oblateness, right? So nobody is, you seem to think that celestial latitude and geographic latitude are perfectly in accord. They aren't. Your question, we have for more than 300 years, we've been investigating the, how long a degree is and how that varies as you move across the Earth's surface. The French meridional missions of the early 1700s, for instance, sort of established this with great precision. So I suggest you look up the geodetic coordinates in on Wikipedia to start looking at the distinctions, because you seem not to really understand the.
You just recently go to Wikipedia, bro. Come on, dude.
Well, is there any reference work that you would like that you trust?
I'm just trying to find out where I can get the International Terrestrial Reference Frame incorporated into any type of star app, Solarium, no, like whatever, Gaia, whatever you think is more accurate, to have a side-by-side to see what your point is. And then once that argument is presented fully, where you think that by adjusting the reference frame to that reference frame, that it'll somehow magically make it more closer to the globe. And then once we do that, and then you have no argument, then I asked you a question. I said, what would be your,
laboring under a misapprehension or a misunderstanding of what I said.
I said, what would be your argument after that? And then you repeated the exact same argument.
What you asked me was, how would you suggest we do this experiment in order to get more accurate results? I said you should look at the way that the ITRF go about establishing their coordinate system and collating the length of day observations.
Yep. I'm looking at that right now. And by the way,
okay.
I didn't ask you for it. You asserted it. You said you should be using this because it's more accurate comparatively to the other 3 sources that were used to get the elevation height of the mountain. So this is, you presented this.
Then we're talking across purposes, because the ITRF has nothing to do with mountain height.
And why the fuck did you bring it up?
Because I thought your question was, how should I clearly misinterpreted his question, because he didn't say how should we more accurately include topography in. You should assume a global.
We need a mountain,
bro. All right, I'm sorry.
Okay. The ITRF don't use mountains, mate, and they get more accurate results than you do. So the saying
accurate compared to what?
The saying that we need mountains is false, because you can do calculate. So
we need a mountain.
Again,
we're testing the Earth, not the star.
You know what the celestial theodolite presentation was about? Do you understand
yes,
what the entire event was about? Okay, you need fucking mountaintops. You need mountain peaks, bro. What are you talking about? No, we don't need mountains to include the stars?
What I am saying is that the entire methodology is intrinsically limited. Now, Cel-Theo pointed out that I was talking about things with excessive accuracy, right? What you guys should be looking at is how the ITRF do their determinations of the shape of the Earth. That is what you should be looking at. If you're trying to test the shape of the Earth, you should be looking at how the ITRF do it, because they are getting results that are vastly more accurate than yours.
Yeah, friendly reminder, this guy's a PhD.
They are also incorporating effects that are vastly more nuanced than the effects that you're considering, and they do not do it by looking at the portion of the atmosphere that has the single largest possibility for refractive influence, and then saying, well, refraction doesn't matter, we can throw that out, and when we do, our preferred model performs better than the stellarium model. If you're going to be looking through the portion of the atmosphere that has the largest refractive effects, you need to include the refractive effects. Then throwing them out is intellectually bankrupt.
Okay, let me ask you a question.
Can you answer the question now?
I got you. This is the last question. So PhD Tony, if you're looking at a star and it gets occluded by a mountain peak, how much is that star being refracted up if we can't see it any longer?
So the light path towards you is always refracted. If that light path is intercepted by the mountain, it is the refracted light path that is intercepted by the mountain. So the point at which you're no longer going to be able to see the star is impacted by the refractive effects and the shape of the light path between the star and you.
Yeah, let's say 2 degrees 31 arc minutes, right? How much refraction should I expect for a star that I can no longer see?
You have
He doesn't understand the light is refracted.
No, it's so I just explained to you why refraction is necessary in this calculation, and now you're asking a question. You should expect the amount of something close to standard refraction effects to apply to the mountain at all times.
He's trying to go with
it doesn't stop. The light doesn't stop refracting just because you can't see it anymore.
It's like if there's a tree fall in the woods, if you can't hear it. I mean, that's the kind of logic you're using.
All right,
right
you want to answer the question then, Zanuck? How much refraction should I expect for a star that is at 2 degrees 31 arc minutes from my location, about 2,000 feet high in sea level.
2 degrees above sea level?
2,000 feet high above sea level, the observer.
Okay, what angle are you looking at from level?
2 degrees, 31 arc minutes. How much
Okay.
refraction should I expect?
I would say anywhere between 0.3 and 0.5 degrees.
Okay, so how much is the star actually refracting if I can no longer see it?
The same amount, you just can't see it anymore. The light is refracting, so refraction is a property of the light as it propagates through the atmosphere. That occurs regardless of whether or not the light then goes on to meet your eye.
So you can
Your
see
eye
things
is not relevant to the refraction of the light path.
They have a real problem with things that you can't see being refracted. They think it's all about what you see, and they don't
How do you know
realize
it's
that
refracting if you can't fucking see it? You guys are
you can go to
fucking
top, you can go, I'll answer you. You can go to the top of Pikes Peak and you can measure the angle to the light and validate that with the person observing 2,000 feet or whatever, 4 miles away or 10 miles away, or however far you are away, with that measurement as well. Take that measurement to the Pikes Peak and the measurement from Pikes Peak onward to the star and compare them. You'll see that they both will add up to what we're talking about here. You have the little refraction
So
to
if
the
you
peak
don't
and
see it,
maybe
you just
more and more.
calculate it. Is that what you're saying? You just
You can
calculate
measure
the
it.
amount of refraction based off of how the angle is to the observer and how high the observer is, right?
I
You
didn't
just calculate it?
I didn't calculate. I said in most cases they're going to range anywhere between a quarter degree and a half a degree for celestial bodies going through the atmosphere at that low of an angle. That's what we generally see. We always see some refraction. I mean,
So you don't even need to see a star to understand how much it's actually refracting. You just need to know what the angle of the star is comparatively to the observer in its
Yeah,
location,
you
right?
could actually do things like go look at the GP, find someone that's actually got the GP to it, see what that angle is, see how far they are away from you, and then compare it to what your angle is measurement to the stars from the Pikes Peak, and you'll probably find out it's pretty close to this refraction value of about a quarter to a half a degree at 2 degrees above the horizon. They talk about this in in sextant manuals. They talk about this, but you have a problem with understanding that something can be refracted even though you can't see it, and it's a curious problem. I understand why you think that, but you can actually prove that to yourself. And we talked about ways you can do that. You use the analogous situation of this, the propane on the metal surface, etc. We have to do a
With your
multiple.
words, nobody has a problem with it being refracted, even though you can't see it. It's just you can't measure it. So
Yeah, exactly.
that's all it is.
You can measure it.
Dude, if I have a glass of water in my hand, okay, and I put a straw in there, and you can see the straw being refracted, all right, you know, you see it, right? If I put that glass of water behind my back, all right, how much is that straw being refracted? Could you tell? Or is it because it's occluded now it's behind my back? You can't tell how much the angle's off, can you?
It hasn't changed. It's still refracted.
It hasn't changed. Nothing in the system has changed. So the amount of refraction that occurs doesn't change depending on whether or not you can see it.
Oh, so it's consistent and it's a calculation.
No.
No, it's not consistent and it's not a calculation.
You can calculate it, and it is consistent. And what happens whether you're looking at it or not? It's not like the double slit experiment.
It is consistent. In consistent conditions, you get consistent refraction. However, refraction in the physical atmosphere is not consistent in the sense that the atmospheric conditions change, therefore refraction effects change. But it is measurable, and it is you can calculate it from measurements of atmospheric conditions, provided you are precise enough in those measurements and diligent enough in collecting the data. Now you can, as Zanuck has said, narrow down the amount of refraction that will occur based on a typical range of atmospheric conditions. You can, so if you're only interested in being accurate about refraction down to the nearest 0.2 of a degree, you can say it 0.1 of a degree. You can say it's somewhere between 0.3 and 0.5 of a degree. That's where it's most likely to lie. Okay, and that is an assumption. But if you are diligent about collecting data, you can in fact correct that estimate.
So it's just an assumption based off
No,
of
it's not.
the geometry of the globe, right? The star
No.
is supposed to follow a certain declination rate, right? And when the star is lingering at the horizon, somewhere near the horizon, about 10 degrees and below, you actually have to incorporate celestial refraction.
So when refraction effects get larger, it becomes more important to include them. Yes, but
I'm just saying that you have to explain the lingering, right?
But the existence of refraction effects is not an assumption. You can demonstrate that refraction effects occur.
Assumption's not.
For instance, you can use the optical position of a celestial object versus the radioastronomical position of a celestial object.
Right, exactly.
You can compare those two things,
right?
You can compare those two data sets to demonstrate that at least one of them has been refracted, right?
At least one. Wait, what do you mean? The true position of the star has nothing to do with refraction. That's why it's called the true position.
But if you're looking at it through a telescope, how do you know
How
do you know the true position of the star?
Yeah. Okay. Well, you just said you're looking through a telescope. That's apparent, right?
Yes,
and then
that's
you can
apparent.
see how
Okay.
that differs from where the true position would be. The true
Okay.
position.
And how are you determining that?
You have a snapshot in time where that zenith of that star that you're observing, wherever that zenith was at a certain time, gives you a certain angle based off of where you are at. And then by adding in 15.4 roughly degrees per hour, you know where that star is going to be. And it's going to be in the same
No, you
cyclical
don't.
pattern.
No, you don't.
So you just don't like stellarium.
You are understand. So you do to a degree, but you don't know precisely where it is going to be just by putting in a 15 point whatever. And I don't think the deviation is that big, but whatever. Just assuming a straight linear angular motion of a star along a particular trajectory. There are again, this is quibbling, but there are variations in Earth's orientation in space. It's rotational poles. So the stars aren't always, a star that is at your azimuth one day may not be at your azimuth the next day. It'll be offset a little bit because the Earth can be, or 1 year versus another year, because the Earth is wobbling around a bit. This is why we conclude that the Earth is wobbling around a bit, because the stellar paths are not consistent. Right, and there are variations in the rate of Earth's rotation.
Okay, and that's the nutation you were talking about earlier.
Yes, well, in addition to nutation, but there are nutation is one of the wobbling things. But the changes in Earth's rotation are actually tidal rotational effects. The effects of the other celestial bodies produce these sort of 2 weekly variations in Earth's rotation. So. And again, this is all measurable. Like if you've got a precise enough laser gyroscope, you can measure these tidal effects on the rate of rotation and the change in length of day, and then you can compare them with your observations.
So just give me an average. You said about 20 meters, just about. How
20
off
meters of what?
is stellarium in terms of calculating the true position of the star? Versus.
I don't know. Well, so
how the fuck do you know that it's inaccurate?
For starters, I didn't say 20 meters. If it's assuming a spheroidal Earth, then it's getting the observer elevation wrong by about 10 kilometers, up to 20 kilometers at some points. It's not. Pardon?
What are you observing? You said observer elevation.
Well, distance between the observer and the an Earth's center of mass.
Distance between the observer and Earth's center of mass.
Yes, can be wrong by as much as 20 kilometers.
And that affects the positions of the stars how and comparatively with the observer?
Well, it affects your timing, right? You're looking at timing effects here, and you're looking at when you're trying to do very precise calculations of angles between the observer, a star, and
a mountain peak.
And a mountain peak. Now, if the difference of oblateness between you and a mountain peak is off by let's say 20 kilometers divided by 1,000, so yeah, let's say 20 meters. Isn't that something that's going to have an impact?
Okay, hypothetically speaking, let's say that the height of the mountain, because this is what we're talking about, the height of the mountain is off by 20 meters, respectively.
Well, it's the relative height between the observer and the mountain, but it's also got to do and you're assuming that there's no curvature between them in your flat Earth calculation. Again, it doesn't give me any. You haven't given me any mechanism.
You have 2 predictions. You have drop over distance with refraction, and then you have a rise over run. That's it.
Rise over run. Tell me what the run is. Tell me what the rise is, because rise and run are not measured in degrees.
Okay.
Rise is measured in meters, as is run. So what are the distances we are measuring?
Hey, you asked a question. All right. The mountain height, in terms of the peak height, from the base of the mountain all the way up to the point, to the tip. Okay. So 2,200 something meters. I don't have the spreadsheet in front of me right now. So, and then the distance is like something like 50 kilometers, something like that.
Okay, but so how does that? How is that
rise over run? And then you get an angle.
How is that relevant to the star?
That's a very good question, Tony, because I'm looking at that mountain peak from that distance, and I know that that height of the mountain is at that height, right? So when I see a star decline in elevation behind the mountain peak, now I can take a snapshot in time and relay that to Stellarium or use any other type of star viewing app like Gaia or something like that, and insert the exact same coordinates of where the observer is, where the peak is, and then where the star should be. And guess what? It's going to match flat Earth.
No, it isn't, because on flat Earth, stars should not follow circular paths unless you are underneath the pole of the pole of rotation. So unless you are under the North Pole, North Pole, star paths should not appear circular. So the star should not be anywhere near where it is for a spherical Earth. It should be describing a completely different geometry, and it isn't.
Okay.
So claiming
What I
that
need you to
it
do is
matches
take the
flat
spreadsheet.
Earth
I'm gonna
is
give it
just
to
an
you.
absolute falsehood.
Hold on. We're gonna get to the nitty gritty. You're a mathematician. I'm sure you'd appreciate it. All right, we're gonna get to the nitty gritty. I'm gonna post a spreadsheet. All right, and we're gonna do the very first measurement. Okay, the very first observation of the star being occulted, which is Pike's Peak. That's the classic. And then once we do that, I want you.
Where are you dropping
I want
this?
you to show.
Where are you dropping the spreadsheet?
Okay, relax, dude. Jeez, I'm about to post it right now. Hang tight.
Is it in live stream
text
chat? Is it in a different chat? Which chat is it in? I was just asking to clarify.
Patience, bro. And what we're gonna do after we do this, I want you to show me why it wouldn't be that angle, that predicted flat Earth angle for that rise and overrun calculation. Because you want to be pedantic, now's your chance.
So what has the star got to do with the rise overrun?
Oh my God, is this guy fucking retarded? He's supposed to be a PhD, you guys.
I have a PhD and I have an honours degree in mathematics. The star has nothing to do with rise overrun to Pike's Peak. Whether or not that elevation angle is, whether or not that angle accords with flat Earth or spheroidal Earth, that the star is irrelevant for that, right?
No, not right.
How is it not right?
I don't know. Can you steelman the celestial theodolite method right now, please, for me, before I continue this conversation? Because I feel like I'm wasting my time.
No, I can't. So why don't you explain it in detail? It seems to be based on something about the star gets hidden behind behind a peak, and the timing is wrong for your assumed flat Earth model. Sorry, for your assumed spherical Earth model, but it seems to be correct for your flat Earth model. And this is counted as evidence against a spheroidal Earth and for a flat Earth. Now, how are you making that argument? Because it does not follow that just because a star has disappeared, somehow the angular height of the peak assumes some different significance.
Okay.
So either you are doing a really bad job of explaining this, because what I understood, I asked you to explain how rise over run is in any way relevant to this. And you said, well, you've got the run to the mountain and you've got the rise by the height of the mountain. Okay.
Does anyone on the globe side want to like step in and explain it to him? Because I don't want to do it anymore.
Well, allow me to straw man what I thought it was before I was talking with you. What I thought it was is that you're assuming that the star is coming down at a 15 degree per hour rate, and it disappears too late, I think, in the spheroidal model, and it appears on time for the flat Earth model. Is that an accurate summary?
Somewhat, but not necessarily. It's not about the accuracy of when it should happen. It's about what actually happened and what does it actually match. Because for both predictions, there are discrepancies. That's not really the issue. The issue is that if it's following this 60 nautical mile per degree relationship with the 15 degree per hour relationship, and that's a ratio, that's a consistency, then you should be getting occlusion times that match more so of the ball rather than flat Earth. But to say it's matching flat Earth is also incorrect, totally. But the fact that you don't have your own occlusion times and that it is not following that relationship, that is a huge issue for your model.
Well, Stellarium is not a perfect spheroidal model. Are we agreed on that?
Okay. And what did I ask her?
What I assumed you had asked was how do professionals in this field overcome the limitations of stellarium? That's what I had assumed your question was. It turned out to be
You
something
said
completely
international
different.
terrestrial reference frame, and then
Yes.
you said, what the hell does that have to do with mountain peaks? Mountain peaks has nothing to do with the international terrestrial reference frame. Then why the fuck did you bring it up in reference to the celestial theodolite?
Because the
it's more accurate
experiment,
if they don't even use
so, okay, to get back to the central point here, do we agree that when starlight passes through the atmosphere, it undergoes refraction? This is a yes or no question.
Wait, what was it? What'd you say?
Do we agree that when starlight passes through the atmosphere, it undergoes refraction? Yes or no?
Sure.
Okay. Do we agree that according to the results presented, if you included refraction effects, the discrepancy between the spheroidal model and the flat Earth model would actually be reversed? That the spheroidal model actually becomes more accurate, as Alsadius pointed out.
So are you asking me to agree that if I incorporated refraction to the angles that are observed, and that it would bring it back to the baseline, essentially, making it, accurate to the occlusion time, that if I incorporated refraction, then it would work?
Yes.
Okay. Yeah. Do you see how that's unfalsifiable then?
No.
Because that's what's in question.
No, because you can verify whether or not refraction occurs, because you can compare radio telescope observations of celestial objects versus optical telescope observations of celestial objects. So if you want to determine whether or not there is refraction of optical signals, that is what you would be using. Right, so it is falsifiable. You can use radio telescopes to determine the true position of objects without refraction.
Radio telescopes to figure out the true position of objects in the sky, like celestial bodies, like stars?
Yes.
Okay, how can you do that when you can't see the star anymore?
Okay. Well, you can, for some stars, use, for instance, neutron detectors. You can detect the position of the sun as it travels under the Earth relative to the position of the neutron detector. So for that particular star, we can track its progress as it moves in a 360-degree arc around the Earth. And when it's above the horizon, it pretty much agrees with, again, some refractive effect. Yes.
Okay.
With some refractive
You're
effects.
challenging the discrepancies, especially at the angles that are at 10 degrees.
Hey, let him finish, man. Can he finish his statement so that y'all can go back and forth?
But the fact that the sun goes under the Earth instantly disproves the flat Earth.
No, that's your assumption.
The idea that tiny discrepancies in the tiny discrepancies near the horizon somehow obviate or negate the fact that the sun appears to be straight down from some locations at a particular time of day. Quibbling, in that scenario, the sun is out of position by at least 90 degrees, according to the flat Earth model. So quibbling over 30 arc seconds is pointless. The sun is 90 degrees out of position according to the neutrino detector as it's passing underneath the Earth from that observer's position.
I don't know what you're talking about, dude. I would recommend just looking at that spreadsheet I posted. Point out the errors that you find, especially with the representation of the globe with atmosphere refraction on, positions of the stars, rise over, anything that you find in error, please study it, etc. So that way we can address it next week on Monday, and then get more accurate.
Again, we have observational evidence that the sun goes beneath the Earth.
I'm not talking about the sun, dude. I'm talking about the celestial satellite. Thank you.
Do you understand the words that are coming out of my mouth?
Yes.
Okay, so why on God's green earth would I waste my finite amount of time quibbling over 27 arc seconds or 27 arc minutes or however the hell much it is, which is well within refractive effects, right? And you're saying, well, the existence of refraction is open to question. The fact that the sun goes beneath the Earth is not open to question. It is detectable with neutrino detectors. So you're here quibbling. This is what frustrates me about the entire fucking exercise. We can know from earthquake data. We can know from distance calculations. We can know from the propagation of atmospheric pressure waves. We can know from fucking photographs from space what the broad geometry of the Earth is. And here you are quibbling over 27 arc seconds or 11 seconds of timing or whatever the hell it is, when we observe the sun to be directly below us using neutrino detectors. Why? Why are you doing this? How does this seem a worthwhile investment of your time?
I think you left, Tony. Was it
Okay.
Beasticles you were talking about? Yeah. I don't see him anymore.
And this whole time, their method doesn't even work. Like, it gives results. If the circumstances are correct, it can be close to flat Earth. It can also match a concave Earth. Some of them match the globe almost perfectly. Some of them match a half-size globe. So it's like, it doesn't even work.
Yeah, and if the Earth were planar, the sun wouldn't set. If the Earth were planar, stars would not go in circular paths. If the Earth were planar, we could use a planar distance, and we can't. And instead they're out here quibbling over these fucking, much smaller than refraction effects. And then when I suggest, well, you could actually test refraction effects. You can actually test it using other instruments. We can detect neutrinos from the sun. We can use radio telescopes on stars to compare their true position. We can use a radio telescope, an optical telescope, and a neutrino detector, all of them trained on the sun, and we can detect their relative positions, and we can determine which two aren't affected by refraction.
You get the same reading on the neutrino detector when the sun's in the sky. Also, though, don't lie.
Pardon, the same reading?
Yeah, you point it at the ground and get the same reading when the sun's in the sky.
No, you don't. The sun is
Show a
discernible.
citation.
The sun is discernible. So
Show a citation.
Sure.
I already have. I've posted the paper and the image of the solar neutrinos. Taken with the neutrino detector. Yeah, I'm running right now. Let's take a look. I'm just helping Tony out because I've already posted this a few times.
Yep. Okay, here's a journal article about detecting neutrinos. You're confused with the fact that there are neutrino sources other than the sun. There are neutrino sources other than the sun, yes, and you do detect those coming through the Earth, even when the sun is above. But the sun is also a source of neutrinos, and it is traceable using neutrino detectors. So you seem to be a little bit confused, I think, in interpretation of this. It is not the case that we detect solar neutrinos coming from the sun when it is coming through the Earth when the sun is above the horizon. And you can quibble again a little bit about this. As the sun rises and sets, refraction kicks in, so the optical effect allows the sun to be visible. But the sun would be invisible to a radio telescope, but detectable by a neutrino detector. And I mean, the flat earthers consistently suggest that they're, and flat earthers are at least asking questions, right? Many flat earthers, it's admirable that they've gone, look, the evidence that I was presented when I was in school was not persuasive to me. It's not in any way conclusive. There are other arguments. That's a perfectly valid thing to say, and it's perfectly valid to say, look, I'm doubting a lot of narratives. I'm finding that a lot of people are being less than honest with me. And I want better reasons. But just rejecting data that disagrees with you is a roadmap to being trapped in delusion. We can use neutrino detectors to track the path of the sun, and it goes underneath the Earth. I've spoken to people in laboratories with them. I've spoken, there are publications about tracking the sun with it. This is not some con or anything like that. And so if the quibbling about including Beasticle's argument seemed to be that including refraction would be inappropriate because the existence of refraction is at question. Well, we can resolve whether or not refraction exists very, very easily. We can demonstrate that it occurs in the laboratory. We can demonstrate that it occurs in surveying. We can demonstrate that it occurs. We could demonstrate that it occurs by tracking celestial objects with radio telescopes or optical telescopes. The radio telescope images will not be refracted. So we can verify the existence of optical refraction effects in the atmosphere extremely easily. And saying that they don't, or that they don't, thank you, Jeremy, you're very helpful. Actually, that's a good reminder. JACE is quite right. Spectrometers easily demonstrate and quantitatively measure refraction. So just you guys, like the flat earthers, you're asking in many cases good questions, and you're not taking anyone's word for it, which is right, but you're just rejecting data that shows that you're wrong. And I don't know, it's hard to think of you as honest if that's the approach you're going to take. If I reject any data that I don't like, I can back up anything that I want.
Preach it, brother. Preach it.
Detector to see if stars go under the Earth as well?
I'm not certain if we can detect neutrinos from particular stars. They're sort of, I think there's a sort of massive background soup of neutrinos coming from all around. So I'm not certain, but it's a good question, so I'll look that up. There are actually some hypotheses for using solar neutrinos to map the interior of the Earth, which is interesting.
Go right through the center of the Earth without any obstruction. How could you possibly map the center of the Earth?
I'm not certain about this. They're claiming that they may be able to pick up some variations in neutrino fluxes. Like, I brought this up at a group meeting with my group, and we were all extremely skeptical, but there are a couple of proposals that are looking at it. They're saying that they can tell how much mass the neutrinos have been through. I don't know. It's a bit beyond my pay grade, that particular question, but it's a good one. I'm a little skeptical of it. Certainly my group leader was extremely skeptical of it. So yeah, but I'm going to answer your question now.
I appreciate your honesty when it comes to you don't know. Neutrinos, as I recall studying effects of something, right? And we call it a neutrino.
Well, neutrinos, neutrinos are a well-tested, subatomic particle.
The effects are there. We can observe the effects.
Yeah, that's true. So to answer the question that was put to me, we can track supernovas using neutrinos and use that to, so they use neutrino detectors to detect sudden changes in neutrino flux, and then they'll start looking there in hopes of seeing a supernova. And they suspect that in the future they may be able to detect neutrino pulsars, binary systems where a neutron star is being consumed by a companion, giving a detectable directional beam of neutrinos. That's a proposal that's out there. Anyway, so there are a couple of individual cases where we can track specific celestial objects other than the sun.
It's pretty cool that something propagates through that much, what we'll call density of medium, and still seem to have no effect on its propagation. I mean, or little, right? There's question on that still.
What happens when a neutrino collides with a refractino?
Was that real?
No. Refractinos are.
I almost
are
Googled it.
Oh man, you can observe the effects of something and label it whatever you want to.
One time I was typing in text and I tried to type refraction, but I got the N and the I on the end swapped, or the N and the O swapped, and it said refractino, and I thought, you know what? That's the new name of the particle that causes refraction.
That's it.
Yep, you found it. Like
They probably published your paper right away too.
graviton, and you got it.
Hey, how many papers have you had published? Thanks.
Not me any.
No, Tony.
Get closer to your mic, Spin. We can't hear you.
Hold on a second. I'm sorry. I had to walk across the room.
Is that better now?
We were talking about peer review months ago, Tony. I was just curious with your with being a scientist. Have you? I mean, I know, for instance, I heard Dr. Blitz the other day on a live say that within the last 5 years, he's published more than a dozen, I guess, papers. And I was like, oh, I wonder how much Tony has done. I'm sure that like that's probably the metric, like within the last X amount of years. But I was just curious. Got his tongue, I guess.
Just break in when you get back, Tony, because I have a question for the room. Did anybody pick up if there's anything new with the celestial theodolite, or was it just the same old, same old?
I came in towards the end and I asked again if they'd had any southern hemisphere observations, and I guess there's a bounty now for that. But I doubt they said anything new. Maybe someone else can shed light on that.
I missed it. Did you say a bounty?
Yeah, for lack of a better term, they're offering a prize. You want to call it that, or a reward for someone either down under or in South America or somewhere south of the southern hemisphere or south of the equator that can provide to them mountain peak star occlusion angles. I guess they're offering up to $300. I don't know that it's an escrow.
Australia's not a great place to do that sort of thing because we don't have great mountains. Like our highest peak is like 2,000 meters above sea level.
Yeah, it's just flat. The whole thing's flat, right, Tony?
Yeah, well, so there is a mountain range called the Great Dividing Range, but it's really old and it has had the shit eroded out of it. I'm still
fascinated by the amount of flat earthers that seem to disengage with your train track measurements.
Yeah.
It's disappointing.
Well, I tried. I don't know. I tried to make it a presentation that was relatively accessible to anyone with high school mathematics, but apparently a lot of people just look at it and say, "Well, it's mathematics. You can make it do anything."
Right. There's like a, you know how it goes. There's a series of catch-all, like insert comment here to like avoid confronting the evidence, and that's one of them. The Pensacola to Jacksonville rail runs right through my hometown in Tallahassee. So
nice.
It was cool to see that. Yeah.
About an hour and a half away from me. I live out in the woods, just south on the Big Bend on the coast.
Oh, do you?
Yeah, man.
Okay. So you live. Okay. So what do you live like in Port St. Joe or somewhere around there?
No. Taylor County.
Taylor County. Oh, okay, cool. I'll look that up. I've heard of the name. I can't remember what cities. But anyways, you were saying, Tony?
Yeah, I was just like, if the Earth is flat, then it should be the case that we can apply planar geometry and we can get a distance calculation. And even if we accept that there are inherent inaccuracies, it should not be an error by 300%. It should give something. It should give something in accord with the distances that we see, and it just rarely does. It's not never correct, but it's only very rarely correct. And it just seems like that should mean something. That should actually mean something to people, but they just go, well, it's mathematics. They assume that you can trick someone, that you can trick people.
Hey, Ducktone. Hi.
Yeah.
I got you some coordinates to two mountain peaks about 25 miles apart that have line of sight to each other in Australia.
Yep. And have you looked at their relative heights?
One is 2421 meters AMSL, and the other is 2519 meters.
Is the 2421 Mount Kosciuszko?
Probably. I don't know. They're just in my data set here. Because one of my YouTube viewers actually went and did a reciprocal zenith during the day between the two mountain peaks with his theodolite.
The first one is in Myeryong, Victoria.
All right, that's a fair way away from where I am. So I'm not sure where you're getting this height from. Mount Kosciuszko is 28 meters above sea level, and it's the highest point in Australia.
Mount Bunanyang. Have you heard of that one, Tony?
No, I haven't heard of either of those. So
yeah, they're both in Victoria, the like southern eastmost region, just
yeah, Victoria is
outside of Melbourne.
Victoria is about 300 miles from where I am right now.
Are you in the greater like Sydney area?
No, I'm in Canberra.
Oh, okay, gotcha.
Oh, I'm sorry. That was feet I was giving you. Feet.
Right. Okay.
Yeah, that's going to be hard for the error measurements, right? 25 feet off the ground.
No, 2,519 feet was the.
Oh, okay.
So that's
But
so that's 800.
But they've got line of sight to each other, and they have nice lookouts, and they've got roads going up there.
Okay. Well, so Alan in his presentation was saying that he wanted sites that are more than 100 kilometers away, more than 120 kilometers away.
He's got. Unless he's changed his pay schedule, it was like $50 for any occlusion. It doubled if it was more than 100 kilometers, and it also doubled if it was in the southern hemisphere, or something like that.
Yeah, he was saying $200 for a southern hemisphere occlusion observation.
Right. So that would be doubled due to being in the southern, and then also doubled due to being over 100 kilometers or whatever.
Yeah, but I guess. Yeah, I guess we could do something like that, but I don't own a car, so I'm not the best person to do this. Also, Alan and I don't get along, so.
Yeah. And besides, we already know what the results are going to be because some simple mathematical formula have been able to predict all of the results so far.
Yeah, as Alcidius made the point that that if he includes refraction, then if he includes refraction effects, then the spherical predictions become the more accurate set. Yep. And Alan spewed a whole bunch of nonsense about central angles that I didn't really understand, and simply refused to include refraction effects. And somebody else made I think it was Beasticles made the argument that the existence of refraction is what's being tested. They're trying to test for whether or not these refraction effects occur. At which point the correct experimental setup would be to compare optical observations of a star versus radio astronomical observations of a star. That's why I was talking about that. I don't know whether or not radio astronomers keep celestial objects in view as they go to the horizon.
What do you think about the argument about the sun having to move faster on a flat Earth in the winter?
Yeah, I mean,
I don't really know how to approach that argument. We were talking about it the other day on QOps server.
Yeah, well, they just they hide behind this kinematic equivalence, and then say, well, we don't know what the forces are, but they must produce results that are kinematically equivalent, which instantly makes their model vastly less parsimonious than the existing model. But yeah, the sun needs to stay aloft, and I don't know how they manage that. And then it needs to accelerate, and I don't know how they manage that. But they just abdicate any responsibility for explaining any of the elements of their model.
Yeah, and I think I made an incorrect statement with saying that the length of a day would be different, because that's not necessarily the case. But we'd be able to measure, like, say between, let's call it like 10 a.m. and 2 p.m. like local time, and do it in several locations, right, to show that at this part of the year, let's say on one of the solstices, right, that you can measure that it's going between 10 a.m. and 2 p.m. It's going faster and covering more sky or something to that effect, like
more ground too.
Its ground position is changing really, really fast.
Yeah, the subsolar point would have to move faster during the winter solstice than the summer solstice. It would have to,
right?
And that's a physical path on the ground.
So if it approached the subsolar point at noon, like how could you make that an argument that would they even pay attention to it? mean, they don't pay attention.
No, though. So I think again, sort of it would boil down to maps. So when I brought up the distance, my distance argument to Geo, he just said, well, you're basically assuming the azimuthal equidistant map there. And in order to make the argument that the sun is moving faster around the Tropic of Capricorn than the Tropic of Cancer, you would have to make the argument that that circle is larger than the outer circle is larger than the interior. As soon as you're making that argument, they'll say, well, that's assuming some sort of AE style map, and we know that that's false because of the 24-hour sun. So you're strawmanning us by using an AE map, and this is where I found it very difficult to sort of clearly communicate the principle. An AE style map is a consequence of how you measure distances, right? You measuring distances from the North Pole, the radius of the Tropic of Cancer must be less than the radius of the equator, which must be less than the radius of the Tropic of Capricorn. But I don't know. They've got some sort of glitch that allows them to sort of work past that. But I think that they would object.
Yeah, it seems like there's much easier arguments that they just dismiss offhand anyway.
Mhm.
So like, why even?
Yeah, and there are many people who keep on trotting out the sunset argument, which MC Toon among them, and I consider that a really strong argument. Like, if it were true, if Earth were planar, the sun should not set.
And by the way, relevant to the topic of the movement of the subsolar point, that also ties directly into the physical spacing, the east-west spacing between lines of longitude. And Ruhif and I have both physically measured with a trundle, a push wheel, the physical surface length of an arc minute of longitude going east-west.
Yeah, that's exactly right. And they're the same. And they've got some weird, like, there are a bunch of people who have some sort of simulation flat Earth model in which they have a different scale for depending on your latitude. So I could get thinner or fatter by moving north or south of where I am. It doesn't make any sense. None of this makes any sense, and I think it's just a geometric ignorance. If they understood geometry and topology well enough, they'd see the inherent problems here, and they just don't, and they can't be convinced that they don't know enough geometry.
I just posted a image that I saw come through earlier. It's from the Travis guy who's been blowing up the chat all night. And what he fails to recognize is the equal spacing in the second photograph, right?
Also the angular size of the light bulb.
That's right. That's right. And I've presented a video that I've got 4 or 5 of them, maybe more, but at least a few of them that were I did pixel measurements. I had a Python program that is able to extract the best circle from any frame. So I ran through all the frames of, for instance, Red's Rhetoric, like 7 or 8 years ago in Tampa Bay, did a sun capture on his P900 or P1000, whatever he had at the time, of all the way from sunrise to sunset, 7:30 in the morning to 7:30 p.m. And I was able to cut out a box, right, for the video editor, or for extracting all the frames, cut out a box where the solar filter around the sun for every single frame, I had the Python program draw a circle around it and put the pixel count next to it. And so for every single frame of the video, the pixels vary slightly, but like it's almost every single frame is like 684, and it goes in increments of 2. I could have probably fixed that, but it'll drop down to 682 like for a frame or 2 here and there, and then it'll go to like 686 every now and then. But the pixel variation is virtually 0, right? It never goes more than the 2 pixels in either direction. And so yeah, and so far nobody's had a real attempt to try and explain it. They just say that they just simply say, why can't that work on a flat Earth? And it's like, well, because the sun's not local. And then they go to, well, at what point does the sun become not local? Like, you know what I mean? They just kind of like go out to just trying to deflect and find a flaw in like whatever I say after.
It has to be, sort of, here they are arguing over like 27 arc minutes or whatever. But okay, at what distance, can I no longer see the sun? What is the distance there? And how accurately do you know that distance? It just seems weird that they're so fixated on details in one area, and then the fact that we can detect the sun under the Earth using a neutrino detector, that's just completely irrelevant. If there is a moderator Does Rich Evans still need to be muted?
Hmm.
I know he was muted during Alan's presentation.
I'm going to post that video I mentioned in case you haven't seen it, but if anyone else wants to see it, it's there. I like it. I mean, even Wesley, before I even knew the kid, he's a good guy. He's in here. He presented my video as an argument to Sovereign Soul, Unchained Mind. He's a go-getter, that guy. But yeah, he just stood with his mouth open and said something about, well, if you see this coffee cup, I can bring the coffee cup closer to the Wesley, maybe you can present what his argument was, because that shit completely missed me. I got to be honest. I have no idea what the guy was talking about.
Just a parent perspective. It didn't make it. I mean, I understand what he's trying to say, but yeah, it wasn't saying what he thought it was saying, of course.
That is a good video.
Thank you.
That Tony or Troy dude, he also posted something like that, but he had it doing the height instead of the width, and of course we know that when it gets near the surface, sometimes it'll compress because of refraction. But of course they do it the worst way possible. Hey Tony.
Yep.
For somebody was asking the other day about relativity and gravity. Do we know, are there theories now for what causes mass to bend and warp space-time?
I think there must be some, but I'm not aware of them. So
Okay.
let me.
Is that what the graviton? I mean, that they're looking for? Is that a
So
field
yeah,
that-
the graviton would be a way for masses to propagate force. Yeah, that's one. That is one mechanism that they're looking at.